For the assignment found on Lesson 01.06 of our Anatomy and Physiology course, we were instructed to use simple materials to construct a model of a bone of our choice.
Our model had to meet at least one of 3 requirements regarding function. It either had to hold the weight of a textbook, protect something soft, or be able to move the same way the bone it represents does.
Our teacher allowed us to work together in groups and complete the project cooperatively if we preferred to. The team would need to plan, prepare, and construct together, working hand in hand, so that is what we decided to do.
After much contemplation, we decided to create 2 bones, the femur, also known as the thigh bone, and the humerus. The femur would meet the requirement of being able to hold the weight of a textbook, while the humerus would hold something soft inside of it. The femur and humerus are both a part of the appendicular skeleton. The word appendicular comes from the prefix append, which means to hang something. The appendicular skeleton contains limbs, the arms and legs, attached to the trunk of the body. For instance, the tibia, radius, and phalanges are all part of the appendicular skeleton.
We sketched our designs and constructed along the way. The primary materials we decided to use were original Sculpey oven baked clay, a hot glue gun, and a sponge, which we not only used to smoothen out the clay, but as a soft object to be held by the humerus.
We decided that compact bone tissue would be represented in each of the models using the clay, and the sponge and the humerus would represent spongy bone tissue and bone marrow.
In order to get the clay to its desirable state for shaping, we had to thoroughly knead it, basically meaning that we pulled, stretched, pressed, and folded the clay until it reached the point of being able to bend without breaking. After the clay was kneaded, we were able to construct.
We based our models off of images found online, plus a video tutorial for the femur, which was found on YouTube. We began by creating the femur, rolling the clay until it formed the shape of a log. Then we continued on to the humerus. Along the way, we measured our models to make sure that they were heading in the right track in terms of size.
As we were constructing our bones, we needed to really consider from time to time what it was that we were making and how to accurately represent it in our models. We were constructing our own bone matrix in a way, consisting of spongy bone, compact bone, and bone marrow. The process which develops the bone matrix is called osteogenesis. Osteogenesis consists of 2 different cells, osteoblasts and osteogenic cells. Osteogenic stem cells can form into any kind of cell when needed, while osteoblast forms the bones and also makes osteocytes. Osteocytes help maintain the bone matrix. Lastly, there are osteoclasts. They break down the bone matrix in order for new layers to be formed.
The building process for making the bones took about 2 days.
After finished shaping, the bones were set in the oven and baked, each for about 60 minutes.
To show that the humerus was able to hold the sponge, the model was made with a hollow opening to one side of it, thus meaning that it would be lighter than the femur, which was packed solid with clay.
The sponge, the soft material, was then placed inside the humerus using hot glue.
To test the femur strength, we first placed the textbook provided by the teacher on the model. Once that held, the teacher then provided us with 2 different textbooks. Those held as well. Although the humerus was specifically designed with the function of protecting a soft object, we decided to test it out to see if it could hold the textbook. Once that held, we tried the 2 other textbooks. And those also held.
Both of our bones turned out to be a success, and the humerus ended up being able to hold the same amount of weight that the femur held, although we did not intend for that to happen in the first place. We did have limitations, however, and the process of working with our materials was not as simple as we expected it to be.
1. Kneading the clay took some time and it wasn't the easiest. 2. Since our femur ended up being approximately 20 inches long and the largest item that we had for it to bake on was 18 inches long, we had to work around that parameter and brainstorm. 3. We also couldn't make the humerus too thin or else a hole might form while it was being hollowed out.
4. The back sides of the bones, also known as the posterior sides of the bones, would be flattened out by the baking pan, so we could not make exact replicas of the femur or humerus. Meanwhile, the anterior sides of the bones, meaning the front sides of the bones, would be shaped and rounded.
5. We couldn't hollow out the humerus before or after it was baked, which made it a lot heavier than it should have been. 6. And lastly, we had to be extremely careful when moving the models from place to place, for because they are made out of clay, they could easily detach and fall apart.
Overall, we worked together as a team and took on various roles throughout the project. We did have barriers and faced some challenges, but we successfully constructed our bones and are very satisfied with the results.